We're going to work on a one mean z-test problem, and I'm going to read the problem to you and I'm going to dissect it. And then from there, I'm going to show you how to calculate it with either the calculator or the website. So suppose that a recent article stated that the mean time spent in jail by a first-time convicted burglar is 4.1 years. A study was then done to see if the mean time has decreased in the new century. A random sample of 107 first-time convicted burglars in the recent year was picked. The mean length of time in jail for the survey was 4 years with a standard deviation of 0.6 years. Suppose that there is somehow known that the population standard deviation is 0.57. Conduct a hypothesis test at the 0.05 level of significance to determine if the mean length of jail time has decreased. Assume the distribution of jail time is approximately normal. So this problem is a one mean z-test because I can say that it is because we have right here, a population standard deviation. We know what that is because it's given to us. So I'm going to highlight it in yellow and I'm just going to post it here. And that's why. And I also know this is a one mean z-test because I'm trying to determine if the mean length of jail time decreased. I'm trying to see if something happened. And in this case, I want to know if the mean length decreased. Okay. So what's the population mean? All right, this one sometimes is harder to see than the sample mean. So let's go look at the sample mean first. Okay. So it says right here, a random sample of 107 first-time convicted burglars was picked. The mean length of time in jail from the survey was 4 years and a standard deviation of 0.6 years. Okay, sample, survey, those all means groups that I took away from the population. So I'm going to go here and the sample mean is 4 years. The sample standard deviation is 0.6 years. And you see here, I'm filling in as I go, and it doesn't matter if I do it in order, I just need to gather my information. So what does that make my population mean? My population mean is 4.1 years, and it said that it's been stated that that's what it has been. So I'm going to do 4.1 years. And again, it might be easier to go find your sample mean and then go from there. Population standard deviation, I knew that is 0.57, and I know that because I had to look for that to determine it was a one mean z-test. All right, level of significance, 0.05, it's given to me. And what's my sample size? And it's right here, it's 107. So I have all the information I need. The next thing I need to do is I need to determine what my hypotheses are. So in this one, it says it's decreasing. And remember, decreasing doesn't mean that it's equal to, it means it's less than. So I could always start with my alternative hypothesis because I know it's less than. So for here, I'm going to put in let me do that. I'm right over here. If you can see it, I'm in the symbols. I'm going to put in the mean. So that means population mean is less than 4.1 years, okay? I'm just trying to compare the sample to the population. So the reverse of that is the mean is greater than or equal to, let me space that out better, greater than or equal to 4.1 years. So basically what I did is I accounted for everything that could happen. It could be less than, it could be equal to, or it could be greater. Remember, that's the crux of what we're doing in hypothesis testing. We're comparing that sample to that population. All right, the next thing I need to do is solve it. So I'm going to do the calculator first. So I've got my calculator here. I'm going to bring it over to here, and I'm going to turn it on. So I do stats, go over to test, and hit enter. I don't have any data, so I click to stats and hit enter so stats flashes at me. And then I scroll down. Oops. So 4.1 is my population mean. My population standard deviation is 0.57. My sample mean is 4. And my sample size is 107. I look at my alternative, which is less than, so I make this less than, I hit enter, and then I hit calculate. So it gives me some really good information. It gives me my z-score and my p. Okay, so I need to do this now on the website. So I'm going to pull up the website. Let me go to that. So I go to calculators. I go to, if I go down, I see z-test calculator for a single sample. So I bring it up. So remember my population mean was 4.1. Now it's asking for something a little bit different in this one. It's asking for the population variance. And in this case, remember my population standard deviation was 0.57. To get the population variance, you do 0.57 squared, okay? So for me, it's going to be 3.249. I'm just going to put all the decimals to make it a little bit more exact. My sample mean is 4, and my sample size is 107. Level of significance was 0.05, and now this is a one-tailed test. How do I know it's a one-tailed test? Remember it said it was less than or greater than, and the alternative means it's a one-tailed test. Not equals means it's a two-tailed test. So I have all my information in there, and I calculate my z-score. And if I scroll down to the bottom, here is my z-score, okay? Now, if I bring up my calculator, they're slightly different for the p-value. So to make this one very similar, I'm only going to do 0.035. And up here, I'm going to round this one up to 0.035. The reason they're different is because of the website wants the variance where the calculator wants the standard deviation. It's not a huge deal. And on the homework, you're going to have to just pick it out of its multiple choice. Now on the test, you'll have to fill in the blank, but we're going to grade these by hand, so don't worry. We're going to be able to see if you get close. All right, so here we go. So I'm going to go back to my problem. All right, so my z-test statistic was negative 1.81. And then, because remember, I'm getting it from both the calculator and the website. And then the p-value, I'm going to do 0.035. All right, so now I have to make a conclusion. So I'm going to compare my p to my alpha. And let me put this symbol in just so you can see what it says, to my alpha, okay? So 0.035 is less than or equal, and we're going to do this because remember, people eat fish from the River Nile, 0.050. Okay, so I'm going to compare this. And what I did is I just added an extra 0 behind the 0.05 to make it look equal. So I know 0.035 is less than 0.050. So what does that mean? That means reject, the null. So I'm rejecting the null hypothesis. So if I reject the null hypothesis, that means I'm not using this one, but I'm going to use this one. So let me highlight that so you know what we're saying. So, okay, so it means the mean is less than 4.1 years. All right, so what can I claim? So I can claim that at the 0.05 level of significance, let me go back up and let's look at it right fast. It wants to know if the mean length of time has decreased. And look, I'm going to be a little bit lazy and I'm going to take the exact wording and put it down here. The mean length of time, jail time has decreased. And that's all it's looking for. And again, the reason I highlighted the yellow is I got that from the exact same problem and I didn't have to really write anything fancy. I just concluded what it was. So again, at the 0.5 level of significance, the mean length of jail time has decreased. And that's all I need to say. That's it. So now we know, based on that sample, the length of jail time is decreased. Again, and it's just for that sample. If I have enough samples, I could take various samples and keep running this and find out if that's a trend that's going on. But for this one sample, I can say that it has decreased. I hope this helps.